Hi everyone, welcome to lecture 22 of your electric circuit class. And in this lecture we are going to cover the RL circuits. The objectives of this lecture: the first objective is to compute the time constant for RL circuit, and the second objective is to use the step-by-step approach to determine voltages and currents in RL circuits. So our RL circuit, first of all, that is first order circuit, because it has one storage element, which is L, inductance, and the response can be expressed in a first order differential equation. Second thing, that the time constant, that is tau, which is equal to L over R Thevenin. So this R Thevenin here is the equivalent resistance looking from the inductance L. The third thing that you should know, that transients occur in inductive circuits because the inductor current cannot change instantaneously. So the current cannot jump from one value to another abruptly. So it takes 5 time constants to reach 99% of the final value. It's exactly the same as the capacitor case. So now the step-by-step approach. The first step, you need to assume a solution of x of t is equal to x of infinity plus x of 0 plus minus x of infinity multiplied by exponential of negative t over tau. And this is, of course, for t greater than 0. That is the first step. The second step, of course, that our x over here, it is voltage or current. It depends on what the question is asking you in that problem. Step number 2, we need to draw the circuit before switch action, replace L by a short circuit, and find IL of 0 minus. So this is the current flowing through the short. So I would like you to pay attention that for this step does not matter what the question is asking you. You have to find the current in the shorted L. Step number 3. Draw the circuit after switch action. Replace the short by a current source with IL of 0 minus value, and that is because IL of 0 plus is equal to IL of 0 minus. So at the instant the current flowing through that short, at the instant before the switch action and after the switch action, they are equal. And then find x of 0 plus, whatever the requirement in the problem is asking you to do. 4, draw the circuit in step 3. Replace the IL of 0 plus current source with a short circuit and find x of infinity. Step number 5, find R Thevenin looking at the circuit from the L location. Step number 6, find the time constant, and in this case tau is equal to L over R Thevenin. And step number 7, evaluate step 1. These are the 7 steps that we need to follow. So let us go over an example over here to show you how we can implement this method. So suppose that we are saying that find the voltage V naught of t for t greater than 0 in the following circuit. This is where we need to find our V naught. That is 2K. This is here is 1 Henry. This is 2 kilo ohm. This is 1 kilo ohm. And this is 6 volts. And the switch is going this way. So the switch was open and closed at t is equal to 0. So our solution here, step 1, assume a solution of, since the question is asking us to find V naught of t, then we will assume a solution of V naught of t to be V naught of infinity plus V naught of 0 plus minus V naught of infinity multiplied by exponential of negative t over tau. This is our solution. So now step number 2, we are saying that to draw the circuit before switch action, replace the L by a short circuit and find IL of 0 minus. This is what we will do. So our circuit for this step, that is negative positive 6 volts. This is 2K, 1K. This is where our switch, so before switch action, so it was open. This is 2K. And this is where over here, our L, right? So we short that. So now we need to find this current, IL of 0 minus, this current over here. So now if we go with this as, let's say, I1, and then we go with this as I2, we are going to write the following equations. For loop 1, that is 2I1 plus 1 times I1 minus I2 is equal to 0. So that means that 3I1 minus I2 is equal to 0. This is, let's say, our first equation. The second equation for loop 2, we have here for loop 2 negative 6 plus 2 I2 plus 1 I2 minus I1 is equal to 0. Then we will have negative I1 plus 3I2 is equal to 6. So we have two equations now and two unknowns. So we can put that in matrix form and solve. That is a 3, negative 1, and the 3 multiplied by I1, I2. That is equal to 0 and 6. So from that, we can get our I1 to be 0.75 milliampere and I2 is 2.25 milliampere. So based on our assumption of the IL of 0 minus, it is going downward. That means our IL of 0 minus, that is equal to I1 minus I2. And I1 is 0.75 minus I2 is 2.25, which means that will be negative 1.5 milliampere. So now we found this value. So now we will go to step number 3. So step 3. For step 3, we said that to draw the circuit after switch action. Replace the short by a current source with a value IL of 0 plus is equal to IL of 0 minus, and then find V naught of 0 plus. So this is our circuit. That is 6 volts. So now our switch is closed. We replace the short with a current source. So let us have more space here. Negative 1.5 milliampere. Please pay attention here. We got our IL of 0 minus to be negative 1.5 milliampere. So negative, and it is going downward. So when we put our current source here, the direction should be downward since we assume that going downward in our circuit. And then we have our 2K here, 1K, and this is 2K. And this is where we need to find the requirement, which is the V naught of 0 plus. So now, if I call this as node 1 and this as node 2, then this over here, since there is a short, that is V2. Then we can write the following. So if you look at V1 and V2, there is in between this 6 volts. That means it is super node. So at super node, we can write V2 minus V1 is equal to 6. and this is our first equation. Then we are gonna write at V1, so V1 over 2. So now if you look at this here, at this point here, we finish that. And then now we will jump to V2. And that is a plus negative 1.5. Then a plus V2 over 2. And that is equal to 0. If I multiply by 2, we will end up with V1 minus 3 plus V2 is equal to 0. That means V1 plus V2 is equal to 3. And this is our second equation. So now we have two equations and two unknowns. So I can put them here. That is negative V1 plus V2 is equal to 6, which is equation 1. And then I have V1 plus V2 is equal to 3, and this is equation 2. So what we need from here is really V2. So if I add these two equations together, we will get rid of V1. Then we will have 2V2 is equal to 9. And from that, our V2 is equal to 4.5 volts. And from our circuits over here, our V0 of 0 plus is equal to V2. And that is equal to 4.5 volts. Now we go to step 4. Step 4, we said that to draw the circuit. In step 3, replace the IL of 0 plus current source by a short circuit and find V0 of infinity. This is what we will do. So this is our circuit here. That is 6 volts. This is 2K, 1K, and this here will be short. So this over here short, right? This is what we did. And then I can get these straight. And this is where we need to find V0 of infinity. This is 2K. So if you look at this here, you can use any analysis technique you want. However, if you look at it by inspection, if there is a current, for example, flowing over here, that current will come over here and it will come over here. Why is that? Because this 2 kilo ohm resistor is shorted out. You see this short here and this short? So there is nothing is flowing through that 2 kilo ohm resistor. Then we can say that our V0 of infinity is equal to 0. If you don't know how to do that, just use any analysis technique. For example, you can go with loop. So if you look at this loop over here, at this loop here, then that will be 2K times I is equal to 0. That means I is 0. So V0 is 2K times I, where I is 0, then we will end up with V0 of infinity to be 0 volt. Step number 5. Step number 5, we said that find R Thevenin looking from L. So now since only independent sources involved, turn them off and use the series parallel or the reduction resistance method. So we are gonna redraw the circuit here. I have 2K, 1K. This is a voltage source, we will short it. This is 2K. This is where our inductor was, right? So I'm gonna look at the whole circuit from here and then find R Thevenin. So in this case, our R Thevenin is equal to 2 parallel with 2, and that is equal to times 2 divided by 2 plus 2, and that is equal to 1 kilo ohm. If you don't know how to do that, just as I told you before, you go with like naming the nodes. Let's say that if I call this A and this B, that means that really this is B and this is B, this is B, that is A, this is A, and this is A. Then we can say that, okay, I have A and I have B. Anything else? That is it. So between A and B, I have this 2K. Between A and B, I have this 2K. And this here between A and A, we don't care about. So that's why we are saying that the two are in parallel. So that is our R Thevenin, 1K. Now step 6, find tau. Our tau for RL circuit is L over R Thevenin. L is 1 Henry and R Thevenin is 1 kilo ohm, and that is equal to 0.001 second. Step 7, evaluate step 1. So our V naught of t is equal to V naught of infinity plus V naught of 0 plus minus V naught of infinity multiplied by exponential of negative t over tau. So when we substitute, our V naught of infinity came out to be 0 plus our V naught of 0 plus came out to be 4.5, then minus 0 multiplied by exponential of negative t divided by 0.001 for tau. And the final answer is 4.5 exponential of negative 1000 t, and that is in volts. And this is our V naught of t. Let's say that how we can deal with it when we have, let's say, a dependent source involved in the circuit. Let us go over an example here. So we would like to find V naught of t for t greater than 0. And this is our circuit here. I have a 3 ohm, 12 volts, We have over here 6 volts. This is 2 ohm, and the switch was closed and open at t is equal to 0. Our Ix is flowing here, and this is 2 ohm. Then we have over here a dependent source, and it is a voltage source. That is, let's say, 2Ix. Then we have our inductor here, and this is where we need to find our V0 across the 4 ohm resistor, and this is 2 Henry. So this is our question. The switch was closed for a long time and then open at t is equal to 0. So we need to find V0 of t for t greater than 0. So now we go with step 1. Step 1, we said that assume V0 of t to be V0 of infinity plus V0 of 0 plus minus V0 of infinity multiplied by exponential of negative t over tau. That is our let's say, solution. Step 2. In step 2, we need to draw the circuit before a switch action. So here, circuit before switch action. Replace L with short, and then find IL of 0 minus. This is what we will do. So our circuit will look like this. That is 3 ohm. This over here is our 12 volts. We come over here, our switch is closed. This is 2. This is 6 volts. This over here where our Ix is flowing. This is 2 ohm. This is a dependent voltage source, which is equal to 2Ix. This is where the L, so we shorted it. And this over here is 4 ohm. So what we need to find is the current in the short, which is this, IL of 0 minus. So if you look at this, the best way to go with that, to go with, let's say, loop analysis. So I will call this as I1, this as I2, and this over here as I3. So we will start with loop 1. So loop 1 is negative 12 plus 3I1 plus 2 times I1 minus I2 plus 6 is equal to 0. We will collect terms, that is 5I1 minus 2I2, and that is equal to negative 12 plus 6, that is negative 6. Bring it to the other side, it will become 6. And that is our first equation. Now, when we go to the second loop, so loop 2, we have minus 6 plus 2 times I2 minus I1 plus 2 I2 plus 2 Ix, that is equal to 0. So we will collect terms. we have negative 2i1, 2i2 plus 2i2, that is 4i2, plus 2ix, that is equal to 6. And this is our second equation. So now we need loop 3. For loop 3, it is minus 2ix plus 4i3, that is equal to 0. So from that we can write it down. 4i3 minus 2ix is equal to 0. And this is our third equation. And now since we have a dependent source, so we need one more equation, which is the controlling variable is ix, and ix is equal to negative I2. From that, we can write I2 plus ix is equal to 0. And this is our fourth equation. So now, if we put this in a matrix form, this is what we are going to get. That is 5 minus 2, 0, 0, minus 2, 4, 0, 2, 0, 0, 4, negative 2, 0, 1, 0, 1. And that is multiplied by I1, I2, I3, and Ix. And that is equal to 6, 6, 0, 0. So now when we solve this set of equations, we are going to get our I1 to be 4 ampere, our I2 to be 7 ampere, our I3 to be negative 3.5 ampere, and our Ix negative 7 ampere. So from that, we can say our IL of 0 minus is equal to what? Is equal to I3. And that is equal to negative 3.5 ampere. Step number 3. We said that circuit, or draw the circuit after switch action. Replace the short with current source equals to IL of 0 plus, and that is equal to IL of 0 minus, and then find the requirement. The requirement in this case is V naught of 0 plus in this step. So this is our circuit. That is a 3 plus minus, this is 12 volts. That is the switch is open. Our Ix is here. This is 2 ohm. Our voltage source, which is the dependent one, is here, and that is 2Ix. We replace our inductance with a current source, and we assume the direction to be this way, but the value came out to be negative 3.5 ampere. So we put it as negative 3.5 ampere. And this is where we need to find V naught of 0 plus, and that is 4. So if you look at this circuit over here, this here really doesn't matter since this is open. So now this current is flowing here, that means really V naught of 0 plus is equal to 4 ohm multiplied by the current source value, and that is equal to negative 14 volts. Now, step 4. Step 4, we said that draw the circuit in step 3, except that over here we are going to what? To short it. This is what we will do. So, short the current source in the circuit in step 3, and then find V naught of infinity. So this is what we will do. Our circuit will look like this. That is a 3 plus minus, this is a 12 volts. Doesn't matter here, it is open. This is our IX, that is 2. This is the dependent source, which is 2IX. We short the current source. And this is our 4. And this is where we need to find V naught of infinity. So if I go with loop analysis, I can go with this over here as I1 and this loop over here as I2. Then we will write our loop equations. Of course that you can use nodal analysis if you want, that is not a problem. If you use nodal analysis, then you will put a node over here, right? And that nodal, for that V, it will be 2IX. Then you need to find the value of your IX. So that is why we went with loop analysis, because it is easier. So loop 1, that is minus 12 plus 3I1 plus 2I1 plus 2IX is equal to 0. So in this case, we have 5I1 plus 2IX is equal to 12. And this is our first equation. So 5I1 plus 2IX is equal to 12. Now loop 2. For loop 2, that is minus 2IX plus 4I2 is equal to 0. So that will be 4I2 minus 2IX is equal to 0. And this is our second equation. However, that our IX in this case is equal to what? And IX is equal to the opposite of I1. So that is negative I1. And from that we can say I1 plus IX is equal to 0. And this is our third equation. So in this case we have 3 equations into 3 unknowns. So we need to find the values for those. So from these 3 equations over here, when you solve them, you are gonna get I1 to be 4 ampere, I2 negative 2 ampere, and IX negative 4 ampere. So if you look at this, our V naught of infinity, that is equal to 4I2. And this is equal to 4 times I2 is negative 2. So that is negative 8 volts. Step 5. Step 5, we need to find R-Thevenin. So our R-Thevenin, if you look at our circuit, it has a dependent source in it. That means we cannot go with the reduction method. So this is our circuit. That is a 3. This is a 12 volts. This is where we have the opening. This is plus minus, and that is 2ix. This is where we have our inductor. And this is 4 ohm. And this value is 2 ohm. This is our Ix flowing here. So this is where we need to find our V-Thevenin. Because R-Thevenin, to find R-Thevenin, we said that R-Thevenin is equal to V-Thevenin over I short circuit. So V-Thevenin is here. This is our ground. If I have this as a plus minus, if you look at this here, that is connected to the ground and there is no current flowing through that, then that is 0. That means really this is our V-Thevenin at that node. So we can write at V-Thevenin, we can say that V-Thevenin is equal to 2Ix. Because if you look at this here, this is V-Thevenin and I have only a voltage source between V-Thevenin node and the ground. So from that, we can say V-Thevenin minus 2Ix is equal to 0. And this is our first equation. And then we have to write an equation for Ix. So, and Ix is equal to what? V-Thevenin minus 12 divided by 5. This is V-Thevenin, this is Ix is going this way. V-Thevenin minus 12 divided by the total resistance, that is 5. So from that we can say V-Thevenin minus 12 is equal to 5Ix. That means V-Thevenin minus 5Ix is equal to 12. And this is our second equation. So now we can put these two equations in matrix form to solve for that. That is V-Thevenin and Ix. And that is 0 and 12. So from that, when we solve it, we will get V-Thevenin is equal to negative 8 volt and Ix is equal negative 4 ampere. So if you remember, earlier we got our I short circuit, right? We got our I short circuit when we have that in step number 4, when we got our V naught of infinity. So our I short circuit, that is the same as our I2 in circuit of step 4, and that is equal to negative 2 ampere. So now our R-Thevenin is equal to V-Thevenin over I short circuit, and V-Thevenin is negative 8, I short circuit is negative 2, and that will be 4 ohm. Step 6 is to find tau. Our tau for RL circuit, that is L over R Thevenin, and that is equal to our L given as 2 Henry, and our R Thevenin came out to be 4, and that will be 0.5 seconds. Now step 7, evaluate to get the final answer. So we said that our V naught of t is equal to V naught of infinity plus V naught of 0 plus minus V naught of infinity exponential of negative t over tau. So we substitute. V naught of infinity came out to be negative 8 plus V naught of 0 plus came out to be negative 14, then minus 8 exponential of negative t over 0.5, and that will be negative 8 minus 6 exponential of negative 2t volts. And this is our answer for our V naught of t for t greater than 0. By this, we are done with the lecture today. So you have to pay attention how to find tau in RL circuit. So our tau in this case L over R Thevenin, and then use step by step approach to solve for voltages or currents in RL circuits. If you know that, you will be in great shape. So our homework is this two problems. Thank you for watching.